Hi everyone, thanks for coming in, and the slides work fine. Cool. So since it was just lunch, let us start off with a small activity. So can you guys stand up, and we're gonna do a very quick activity. And I know you don't like it, but let's do this. So it's called the open web stretch. It's gonna be fun. So I want you all to raise your hands up to reach your open source dreams. Now bend down to touch your toes to reach the grassroots. Now come back up and feel the waves of change. Now put your hands forward and shake the money tree for fundraising. Now lean towards your left to avoid the NSA. Lean towards your right to avoid the NSA. Now lean all around matrix style to avoid the NSA. Thank you so much. You can take back your seats. Okay, so today I'm going to be talking about how we invented our own protocol to make the world work faster. So it's kind of a very cheesy title, right? So let's just call it the Universal Realtime Protocol. So a little about me, I'm Srushtika Neelakantam, and I've been a long-time contributor at Mozilla, where I'm involved with the Tech Speakers program, the Reps program, as well as the Campus Advisory Committee. Earlier this year, I co-authored a book with a friend titled Learning Web-Based Virtual Reality, which was published by APRIS. And currently, I'm a developer evangelist for a company called Deepstream Hub, which is based out of Berlin. Have any of you heard of the company called Deepstream Hub? No. So let me give you a little context before we move on, because it's very much related to what I'm going to speak about. So Deepstream Hub has an open real-time server called Deepstream.io, using which you can build real-time applications out of the box. So it gives you all the features, real-time features like PubSub and whatever you think about. I'm going to actually cover those things in the presentation. And you can just build your applications with the clients that they've already built for you. So real-time, what exactly is real-time? So there's a lot of misconception around the term real-time, the real-time web, and the technology is general, right? A lot of people feel that basically real-time technology means the data being available instantly, as soon as it is produced by some creator of the data, right? But that's a misconception. Although it feels very correct, it's not really correct. Real-time basically means the data is available within a certain deadline from when it is created. And this deadline depends on your use case, basically. But, sorry. But from what we know of the internet and how applications work currently, how do these real-time applications work? So we have the slide where you see a lot of different real-time applications, like you have real-time stock updates, you have the text collaboration tools, chat applications, notifications, and also the Uber app. So how do these applications came into being, and how can you, as developers, build something on your own? So we'll actually explore what goes beneath the hood for real-time applications, and we'll see how developers can build their own applications. So before we move forward, it's just an explicit warning that there's going to be super oversimplification of stuff. I'm going to cover like super basics, and there are chances that you already know some of this stuff. But bear with me, this is basically to bust all the myths around this real-time world in general. Right. So, ta-da, HTTP. Now don't worry, by oversimplification, I did not mean that I will explain HTTP to you, because you pretty much already know this. We just have a client, a server, and the client, like always, sends a request to the server asking for some service or data, and depending on the availability of the service or the data, the server responds back with a response, right? But in this kind of a scenario, when you think about our use case, for instance, the Uber app that we saw, how would the client actually know when the server has some new data to share? So how would it look like in such a scenario? The client would be like, hey server, do you have any new location data that I'm supposed to know? And probably the server would be like, so here's your data. Or maybe say, no, I don't have any new location data that you might be interested in. But we are continuously interested in getting such kind of updates, right? So HTTP is not really useful for us. What else can we do in such a scenario is something called AJAX polling. With this, it is exactly the same as the HTTP request and response cycle, but again, it happens frequently after every interval. So the client would ask the server again and again for some updates, saying, hey server, do you know if the car has changed the position? Do you know if there's any new data that you are aware of that I'm supposed to know? And But what happens here is every time you send the request and get a response back, there are all the connection setup and validation steps involved. So this is a huge overhead when you do it again and again. And chances are that out of 10 requests and responses that you send, 7 of the responses, the server would just return empty-handed saying, hey, I don't have any real data to give back to you because there was no data generated in this amount of time. Which is just redundant, right? How can we reduce this kind of a thing? One improvement over AJAX polling is AJAX long polling, in which, again, you send a request and expect a response back, but you don't expect a response immediately. You persist the connection for a bit. What I mean by this is you ask the server saying, hey, do you have any new location data that I'm supposed to know? And wait for the server to actually get access to some new data that is currently being created. So you persist, you keep the connection open for a bit longer, and then expect the server to return back with some actual data and not empty-handed. But even in this case, it's not necessary that the server actually returns back with data, right? It can still say that, no, I still don't have any data. So, and also the amount for which you can keep the connection open, or the time for which you can keep the connection persistent is limited. So there is some particular time at which the server eventually has to return back a response. Again, when it returns back a response, you repeat the same cycle again and again at regular intervals like we saw in AJAX polling. Again, this is not something we would like to do when we think about an application like Uber, where you continuously wish to get location updates of your car. Now, with HTTP version 2, we have a provision for batching requests and responses. But when you think about a use case like ours, what would these 3 requests look like? Request 1, hey server, do you have any new location data? Request 2, hey server, do you have any new location data? And request 3, do you have any new location data? So it's the same request and again. And just to save on setting up 3 different request and response cycle, HTTP version 2 is actually helping us group those and send them in one go. But for real time, in the real time sense, that still doesn't help us. So what's wrong? All right. What are we actually trying to do in all these protocols? In these protocols, we're expecting the client to somehow magically know when the server has access to some data, and we're trying to get that particular data. But in fact, the client has no idea when something has changed. It is a server who has access to the person who's creating the data, for instance, say GPS in this case, and the server is the person who knows, okay, there's some data being created, and there might be people who are interested in. So wouldn't it be better if the server just sent the data by itself without someone trying to ask it again and again? So this particular thing is called the push paradigm, as opposed to the pull paradigm, where the client is pulling some data from the server, but the server itself is pushing something to the client, to the interested client, and not to all the clients which are connected to it. But again, from what we know of how the internet works, or how this HTTP and everything is set up, how can the server initiate a connection by its own? How can it say, hey, you know what, client, I'm going to send you some data, but for doing that, it has to know that there is a client which is connected to it, and yada, yada, yada. We know the drill, right? So I know some of you are already smiling. You know what's coming. It's called the WEBSOCKETS protocol. So basically, WEBSOCKETS protocol is sockets on the web, so you can now use those in your web browser itself. So it initially starts off as a HTTP handshake itself, where the client would be like, hey server, you know what? I have some use case for which we might have to talk in the WebSockets language, so how about we just do that? And depending on if the connection was successful, and if the server actually knows the WebSockets language, that is, if it supports WebSockets, it will return back a response saying, okay, sure, let's talk in the WebSockets language. And from there on, the connection is full duplex and persistent. What I mean by this is the client and the server can now communicate with each other simultaneously and continuously. The term persistent means that the connection is actually kept open for as long as your application is running. So there's no time limit like we saw in AJAX polling that, it is within this amount of time that the server has to return back something, otherwise the server loses contact with all its client. It's always open for as long as your application is running. Then when you're done with using the application, or one of them call it quits, and the connection is terminated. So that's how it basically works. Now it makes sense for the push paradigm to work, right? Now the server knows that, okay, I'm connected to this particular client, and the client looks interested, and I'm connected to this GPS who's actually providing me some data, And maybe the client, because the client said he was interested in knowing this, let me just send it to him. And it can actually now do that because it is continuously connected to the client. Now it all makes sense, right? So now that we know what goes beneath the hood, or we understand the mechanics of how these real-time systems work, let's explore the different features that come along when you think about real-time applications. But before I move forward, when we saw WebSockets, I would like to mention that is WebSockets the only protocol that you have to use when you think about real-time applications? The answer is no. There are a lot of other protocols that might be helpful for you depending on your use case. For instance, if you're thinking about IoT sensors, where you have temperature sensors streaming some data, data to the users who might be interested in that data. If you try to implement WebSockets protocol on those sensors, which are really low power devices, it becomes very complex, and you can't really expect them to have a continuous open connection because they'll soon drain out of battery and die. And that's not what we want to do. Also, with temperature sensors, the temperature doesn't necessarily change every 10 milliseconds or even 1 second, right? We can easily give it like 15 minutes or half an hour window where we can make a HTTP request again and again, like every 15 minutes or so, and ask it for updates. So WebSockets, in that case, doesn't really make sense. And we also have some protocols like MQTT, which I'll talk about later on, which are really lightweight and real-time as well. And you can use them depending on the use case that your application is particularly trying to implement. So coming back to the features, we have all these features, and let's actually look at what all these are one by one. So starting with PubSub, a very catchy term, PubSub. It's actually a shorthand for the publish-subscribe messaging pattern. So what happens in publish-subscribe is, say you have your newspaper boy or the magazines that you subscribe to every month, right? What you do is just subscribe to the newspaper, pay the subscription, and just wait. And it is delivered to your home by itself. You don't go to the shop every morning to buy the newspaper again and again. It's exactly how PubSub works. So there are certain publishers who are publishing certain data, and there are subscribers who might be interested in the data that the publishers are publishing. And you would just let them know that you're interested, and they will automatically give that data back to you. But how publish-subscribe works is in two different ways, topic-based as well as content-based. In topic-based, the publishers publish the data that they're publishing in certain channels only. So it's like a TV where you have certain channels, and you can look at only those channels, and all that they're showing in the channel, even the shows that you don't really like, you have to really look at those, because that's the only way. But whereas in content-based, publishers are basically publishing all the data that they're supposed to, and the client or the subscribers have a way to ask or request for a specific subset of that complete data. But even though we say publishers are giving the data to the clients, there's always this middleman called the server or the gateway or the router who's actually doing this filtering and the routing job, right? So that's exactly what's happening in here. And next we have the data sync feature. Now data sync is by far the most powerful feature when you think about real-time applications. For instance, you can imagine Google Docs, right? What happens there is you are collaborating on a document with your friend who's sitting somewhere in some other corner of the world in real time. So you say type a letter A, and the person can see that you're typing the letter A at almost the same time. But it is I say it is the most complex feature to implement as such because it is really important to maintain the same state of the application across all the clients, all the distributed clients at any given point of time, right? Would you imagine yourself typing a sentence that your friend who is also collaborating on the same document is actually trying to delete? That never happens with us, right? The logic behind this particular feature takes care that it is exactly the same particular state. Even if you happen to lose the network at some point of time, when you get back the network connection, it restores the state that is available that all the other clients are looking at that particular moment as well. So there's no you don't basically screw up your application as such. And we have presence. Now we all use social media, and we know that green button that appears next to the people who are online currently in that application while we're using it as well. That happens with a feature called presence. We basically know who else is present on that same application along with us. And there are also some ways in which you can query for a particular user saying, hey, you know what, server, is my friend Sam online right now? And the server would be like yes or no, depending on his availability. So that's one thing. And we have RPCs. Now, RPCs are interesting. They are remote procedure calls. We all have done function calls in our code, right? The only difference with RPCs is that the function that you're calling with the parameters that you send does not essentially exist on the same machine. It can reside on any machine at any corner of the world, and you can still call that function by sending it some parameters, and it can return back some data after processing that the parameters that you've sent. Now, how it happens is there may be multiple people who are providing the same RPC. It's not just one person. So I have I'm sitting in Berlin, and there are providers, say one in Singapore and one in the US. And when I tell the server that, hey, you know what, I'm interested in this particular function, and these are the parameters, my server would choose one of the providers which are providing randomly so as to load balance the whole thing. And after choosing it randomly, it'll give it the parameters that my client has sent, let it process it, and give back the result back to the client. And it all happens so fast in real time that it appears almost as if the function was residing in your own machine, like you would do the regular function calls. But what exactly is listening? Listening is something new, right? We haven't really heard of listening a lot. Listening is not a particular feature by itself. It's actually some kind of an enhancement over the pub sub feature that we just saw. So I'll actually talk about listening in a bit, and not exactly now, because we need to gain some more context before we can understand what listening is. So now that we know what are the different features that you can have within your real-time applications, what are the options that you have to build build such real-time applications? Would you imagine yourself to completely reinvent the wheel and start implementing like the WebSockets protocol again? Or maybe if you're like using some libraries that already provide you with the WebSockets architecture as such, would you actually build all these features from scratch? You wouldn't really do that, right? We have a lot of options in the market, a lot of infrastructure as a service, or standalone servers, or even platform as a service that are available out there. But they all provide like certain features. Maybe not all the features that I mentioned. All of them have like a subset of these features that are provided. A couple of them are even open source, so you can go about and see how the particular feature was actually built. And learn a lot and implement it in your own applications. With some of them, you can actually integrate them while you're starting to build your application. And with some others, for instance, with deepstream IO, you can actually plug it in while you're halfway through your application, and you suddenly think that, okay, this particular thing would be good to have in a real-time sense. So what is exactly the problem? We already have such services, right, to just use out of the box. So all these services that we just saw would have implemented some kind of a protocol to be used with their own SDKs, with their own clients or the APIs that are developer-facing, that are used within their organization. But all these clients or the APIs that they provide are limited. For instance, say deepstream has a JavaScript client and a maybe Android client. What if I was like a Go programming person and I don't have a client to use with the Go programming language? That is a problem, right? So what we did was the protocol that we use at deepstream, the real-time protocol which does all this process, we built it and then we open sourced it. So now you can actually build your own clients in the language of your own choice, and then use them to build real-time applications, or just open source those clients as well, so other developers can build real-time applications on top of those clients. So we call this URP, or the Universal Realtime Protocol. So it is basically an open standard, open real-time protocol standard that you would use to build your own clients. You can either build it on bare TCPs or over WebSockets, and you have these multiple clients which talk to each other via URP. So it looks something like this. So URP behaves like this router or the server or the gateway in the middle, which does all the exchange of messages, or like it routes the correct messages to the correct clients. And here we call both the publishers who are creating or publishing the data as clients, as well as the people who are consuming the data as clients. So for URP, it's just a client. And all these clients are basically completely decoupled. So this client 5 right here might not even know the existence of all the other 4 clients as such. So, and because ERP provides you with a particular message format using which all the clients are basically built, you don't have to worry about interoperability. They're all compatible all the time. So even if like I have like client 5 built in Kotlin and I have my client 3 built in Go, they can still communicate with each other via ERP. So why exactly ERP came into being? First of all, as I said, it is open source. We believe that it would generally, benefit the developer circles as such to have such an open standard for real-time applications, using which you can build your own clients as such, and not just the end applications that people use on their devices. Also, it is a binary protocol. It uses binary protocol and as opposed to the text protocol. So we used to use the text protocol at deepstream earlier, and we switched to the binary protocol, and after we ran some tests, we actually realized that there was around like more than 30% increase in speed, because with binary, you don't have to really exchange a lot of information or a lot of data, right? You exchange minimum length payloads, but you're still exchanging a lot of information with just those minimum payloads. That's exactly why binary protocol is useful. Again, as I mentioned, it is cross-language. You can build clients in any language because it has a standard message format, so all those become interoperable at the end. And there are location-transparent microservices that scale. So what happens at scale when you have like a lot of messages flowing through ERP? Is it like a single node which has to deal with all the complexity of having so many different clients? Well, it scales automatically as per the need, and it forms a cluster of nodes, and all these nodes are completely synchronized and maintain the exact same state at any given point of time. So you don't have to deal with that on your own, even if you're building the clients and not just the end user real-time applications. Also, ERP provides authentication and permissioning handshakes over which you can build your own logic, or you can basically plug in your own database that you already have with certain users and stuff like that. You can just basically plug in your own language, but then there are formats for that as well, so everything basically becomes a lot simpler. So what do we already have? Do we have already such a protocol like ERP, or is ERP a completely new thing? Well, something that is the most nearest to ERP is called WAMP. Now, if some of you are PHP developers and if you've worked with WAMP server, that's something completely different. WAMP protocol is called the Web Application Messaging Protocol, and it is very much similar to how ERP is built, but it provides only publish, subscribe, and RPCs as features. It doesn't have all the other features like data sync and presence that we talked about. And we have the Java message service. With Java message service, it basically provides you the APIs and not exactly the message format. So it's not necessary that the clients you build with it are interoperable. They might be incompatible as well. And we have the AMQP, which is the Advanced Message Queuing Protocol. This particular protocol is very helpful to serve like a message layer between your backend clients to communicate with each other. But when you think about clients which are both like front-facing, front-end, as well as a publisher which sits at the back, it's not really a key player in such kind of scenarios. Next, we also have MQTT, which, as I mentioned, is a super lightweight protocol that is mostly used with IoT sensor devices. And ERP is currently thriving to reach the kind of support that MQTT currently provides. So this slide and the next slide are very ugly looking slides, so bear with me on this. So this is like the basic message format that we have in ERP. So I'm going to quickly run through this so that you understand how exactly it functions and how people can build their own clients. So we have like a final bit which tells you if this is like the end of the message that you're trying to send. And we have the topic, which is the general purpose of the message. So we have like publish subscribe, right? Within publish subscribe, we have events. So say one of the clients emits an event and there are subscribers who are interested in getting updates whenever that event is emitted. So topic will tell you that, hey, you know what? Event is something that I'm trying to, I'm trying to talk something about the event, so that's my general purpose. And then action would be what exactly I'm trying to do with that event. Am I subscribing to the event? Am I unsubscribing to the event? Or am I emitting the event? And stuff like that. But all this information is actually in binary format, and these are enums. So you don't really have to deal with the complexity of parsing all this and then spend any more time on it. So everything becomes like as fast as possible. And then you have the payload, and if the final bit is not set, the rest of the payloads which come in the further messages are added to the payload previously received, and then when the fin bit is set, it knows that it is the end of the message, and it'll just add all of those payload, and the whole thing becomes a message as such, which is really simple to implement, right? For if you think about building certain clients by yourself. So let's exactly see what happens in, say, one kind of a thing, which is events, like I just mentioned. Let's see what exactly goes step by step when you try to implement your own client. So say we have a client A implemented in some language of your choice, client B implemented in, say, some other language of your choice. The client A has no idea of the existence of client B, and the same with client B as well. And we assume that they're already authenticated, so let's start from here. So the client A is actually trying to subscribe to an event named cats. So it'll tell ERP that, hey, you know what, I'm interested in event named cats, and whenever something happens with regard to this event, please let me know. And optionally with ERP, you can have acknowledgements or not. So in this case, we do have acknowledgements. So the ERP will tell back client A saying, hey, so okay, I get that you would like to get notifications about this thing called cats, and I will send you whenever something happens. So that's just an acknowledgement sent. And thanks to the permissioning and authentication formats that I was mentioning, you can deny certain clients certain actions that they're not supposed to do. So say, for some reason, we don't want the client A to subscribe to an event named dogs. Maybe we know that the client A doesn't like dogs, so we just don't want him to know anything that happens with regard to dogs. So we would be like, you know what, you don't have the permission to subscribe to this event, so I'm just denying you right here. And then if some other client is emitting some event for which there are no subscribers as such, it'll basically discard it, because there's no point in retaining it. It's real time, right? So it becomes stale if it is not transmitted immediately. So it just discards it. And then if one of the clients actually emits an event for which we have a subscriber, in this case the cats, it will just directly forward that the payload that is part of that particular event to the person who subscribed to it. And again, if the client who subscribed tries to send back that same payload back to the originator of the message, ERP doesn't let any of the unnecessary data flow, and it will just not let the person send back the same data again and again. And when you're unsubscribing, obviously again it will be like, okay, so you don't want any updates further on, I'll not give you any updates. And that's basically like very simple implementation of all that happens within real time. And all the other features as well that we've been speaking about have such very basic and simplistic implementation as well. Now let's get back to the feature that I mentioned before called listening, because we now have a little more context to understand what happens within it. So with listening, now let us consider the publish and subscribe pattern, where the publishers were streaming some kind of data and the subscribers were interested in that kind of data, right? And we will take the example of deepstream server. So deepstream is basically an implementation of ERP, right? You can also implement something else which is similar to deepstream, and it will be another ERP compliant client. So here I have deepstream, and I have these 3 data providers, or say publishers as we call it, and they are providing data like different subsets of data. For instance, the first one is providing everything, like the whole data of the whole world. I don't know how it's managing to do that, but it's doing so somehow. And then the second provider is providing data for just the country, Germany. And the third one is providing data for just the country, Poland. And here we have 3 subscribers. The first one is interested to know the whole data. I don't know what he's trying to do with the whole weather data of the whole world, but he's just interested. So deepstream will be like, hey, you know what? I have a provider who's giving you the data, and it'll just give back the real-time streaming data in real time to the client. And we have a person who's interested in Germany. We also have a person who's interested in a particular city within Germany called Berlin, and which is provided again by the second provider itself, so it'll do that. But what happens to the third guy who's providing Poland data? Well, traditionally, what would happen was this provider would still provide the data, stream all the data he has, and the deepstream server, which is sitting in the middle, will have to deal with all the complexity of having so much data to deal with and not having any clients to forward it to. It'll just be like, okay, I have this data, I'm just dealing with this data for no reason at all, I still don't have any clients. What if there was a way to just tell the provider that, you know what, don't give me the data unless there's someone who needs it? So that's exactly what listening does. So even though there is a provider for Poland, since we don't have any clients, it just does not provide any data at all. And as soon as there's a client that appears who would be like, hey, you know what, I'm interested in the data in the weather data for Poland, deepstream would instantly be like, hey, there's work for you. So you just start streaming your data, I'm going to give it to the client. And even if we have like another client which comes up when someone is already providing the data, more the merrier, because the publisher is already publishing the data, deepstream will be like, okay, so I'm going to give you this data as well. And again, if people start unsubscribing and there is a situation where there is no client who's no longer interested in one of the data that one of these providers is providing, it'll again tell them that, okay, stop providing for now because we don't have any more clients to listen to, which is very efficient, right? We don't, this server thing or like the router in the middle does not have to deal with so much data unnecessarily at all, since there are no clients for that particular data. And listening is an exclusive feature. I don't know why it was not implemented before, but it is an exclusive feature which is part of ERP, and it's not really implemented before with any of the other services we saw before. So let's get to demo. Now I'll show you a very simple demo. So if you attended Dan's talk, it was a very interesting demo where you got to interact with the screen as well. But mine is a very simple demo where I'll just show you how emitting an event and subscribing to the event works. I'll just show you like a publisher who's publishing some data and the subscriber who subscribed to the data. And we'll do this using one of the implementations of client. I see weird music playing in the background for some reason. Okay, so we'll use deepstream as an implementation of the ERP protocol to look at an example here. So if you see here, I have a very simple index file which is not visible. Just a second. Is it visible now? Okay, great. So we have an index.html file which is just referencing to the JavaScript client provided by Deepstream. These are the kinds of clients that you will be looking at building if you're using ERP. And I just have a client file, JavaScript file, and I have a h1 tag within which I have some, here if you see, I have some data, I have some text called events example, and I will try to replace the data that I receive as part of the event with this data. So it's very simple, right? And if we go to the client.js, you initially need to connect to Deepstream. So Deepstream, as I said, is an open real-time server. So let's go back and start this server. So I would just say Deepstream start, and it would start the server for me. And as you can see, Deepstream provides both the WebSockets implementation, which is running on port 6020, as well as the HTTP implementation, which is running on port 8080. So depending on your use case, as I said, you just go about using one of the servers out of the two. Now, since it is events, it is publish, subscribe, and we necessarily have to have like a persistent connection, we'll use WebSockets, which is on 6020. That's exactly the same thing that you see here. So we have connected to Deepstream on the port 6020, and then we say, then we make the client to log in. There are a lot of different ways you can log in with, like email authentication, file authentication, or even webhook authentication. This webhook authentication is the one where you go about including your own database of users and stuff like that. But here, since it's just a demo, I'm just going to have no authentication, which is one of the type of authentication that Deepstream comes with. So I'm not sending any parameters, no security, no problem. So I'm just going to make this client subscribe to an event called my event, and all I'm doing is just calling a callback whenever something happens in that event. So whenever there is any change in the data or that event is emitted, I will be notified, and I'm just replacing this events example text with the data that I'm receiving from the person who's emitting that event. In this case, it is the publisher.js file. So usually, how it would exactly happen is that there would be an external change in the environment that would actually trigger an emission of an event, right? But here, just for the sake of the demo, we are making the publisher just emit the event for no reason at all. So I'm just saying set interval after every 1 second, just emit the data, just because I want to see what goes about, what happens right here. So it's exactly the same way. It's a node client, so I would connect to the JS client. I would require that file, and I'm again connecting to deepstream on WebSockets. I will call the login method, and after the login is successful, I'm just saying, hey, you know what? Emit this particular event by the name my event, which is exactly the same that the client is subscribed to. And we are sending the data as the current date and time. Now, why the current date and time? Because we want to see different data every time, right? Even though we are mimicking some kind of a real life publisher, we can't have like the same data and expect to see changes. So it's just date.now. And let's actually go to the browser and run this file. And just have to reload this, and it works. So now I'm coming back here, and now I'm making the publisher to publish this particular event, right? To emit this event. So I would just say, okay, I was not in the right place. I'm coming to the console, and I would just say node publisher.js. And as you see, as soon as I hit the enter button, after each second, it emits new data. It says new data published. And as it is publishing some data, you can see the client getting that data. Now, did I go back to the browser and actually refresh the page to get that new data? No, right? It is exactly the push paradigm that I was talking about. Since it had established a connection with deepstream already, and deepstream knew that there is a publisher and the subscriber who's interested in this kind of an event, it just pushes the data to the client every time it changes. Now, you might think that because it is on the same machine, that's the reason why it happens so quick. Even though it is on the same machine, still all the message exchange is happening via deepstream, right? So it would be exactly the same even if like I had the publisher in one corner of the world and like the subscriber in some other corner of the world. So that's pretty much about it. Getting back to the presentation. So we now know everything about real-time technology, what goes beneath the hood, and what are the different services that exist, and what are the different protocols, and what ERP exactly is. But why even did we build this kind of a protocol? Why do we need such protocols like this? Now, if a survey on the internet, which is sponsored by Seagate, is to be believed, by 2025, there will be 30% of all the data-driven applications, of all the data that actually lies out there, 30% of that data is going to be real-time. So with such an increasing level of real-time applications and all the data that revolves around us, isn't it high time we had such a open real-time standard protocol for applications that developers can just utilize and build clients for? That's what ERP is for. Thank you very much. So do you have any questions right now? You can also come grab me later. I'm going to be around. And you can also ping me on Twitter. That's my handle on Twitter. No questions? Yes?
What was it implemented in?
Sorry?
What technology did you use?
Node.js.
Oh, you did?
Yeah. Any more questions? So we are good. Yeah, one more question.
Is there any well-known usage of
To be honest, it released like this week, maybe. So deepstream is the only client currently for ERP, but you can start building clients by yourself. So currently it's just deepstream and nothing else. Yes?
What implementation do you provide for this protocol? I mean, you have the JavaScript library for client. You have like C++ library or something?
So the libraries that I showed were actually clients that were built on top of deepstream. So deepstream is like a client. So you have like the JavaScript client and etc. So if you're building some other client, say Go client, it can actually communicate with deepstream client itself via ERP. But currently with deepstream, we have like a JavaScript client, a Java client, Swift client, and Android client, and a lot of other clients as well. But obviously, we haven't covered like all the programming languages that exist. Yeah. Any more questions? Yeah. Maybe we can take that question offline. Yeah.
But the
Yeah.
I could make another implementation.
Yes, of course. That's the idea for the developers to make an implementation similar to deepstream and just work on it. So even though there is a JavaScript client that exists, thanks to deepstream, you can still implement one more JavaScript client if you please and just use your own implementation as such. Cool. Cool, thank you very much.